So from this previous conversation, you are saying like the amount of data directly influences the performance of a model, like how good it's going to perform, right? If I have a large data set, I can make accurate predictions, right? Is there something else that also affects it? Like we know that not the input alone is not going to influence our learning process. There are going to be so many other things that influence our learning process as human beings. So for the model itself, apart from the input data set, do you see like what are the other factors that could influence how good it's going to predict the result?
Yeah, one thing could be the complexity of the model. Some tasks
Okay.
could be very, I mean, we use our human brain, which consists of millions or billions of neurons,
Hmm.
or more than that. I'm not sure.
Depends on who you're talking
But
to.
yeah, it's a really complex structure.
Yeah.
Yeah, so for a model to do something really complex, it has to have these kind of complexities in order to achieve that. So that is one factor which can influence how good a model performs. And thanks to the improvements in hardware in the recent times, we are able to use some very, very complex models which were kind of impossible to use maybe
Previously. Okay.
10 years back.
Yeah, so I have a question on the hardware. So you said the hardware helps us do more complex algorithms or do like perform them. But does that impact the ability to perform or just the time taken to finish it? Or both?
Both.
Okay.
One, if you think about the ability to train this model, earlier it could have maybe taken say 2 months to train this model. Maybe now it's possible to train this model in a day, or
Okay.
and also the memory of the graphics cards have also increased.
Mm-hmm.
So earlier, even if you had large amounts of data, you had to use them in smaller batches,
Chunks. Mm-hmm.
smaller chunks, in order to fit it into the graphics card that you have. But now that has also increased, and now
Mm-hmm.
you can fit larger chunks of data into the graphics cards, and that has also helped in training the models better, because when you use larger chunks of data, it's going to lead to better improvements in the model than smaller chunks.
So,
Okay.
has the improvements in hardware technology aided in the development of, say, machine learning? Because I'm
Yes,
guessing in a
definitely.
world where graphics card were not so popular, I'm guessing image processing would not have been something that you could do in your system, right?
Yeah, exactly. So these neural networks were actually proposed in sometime in the 1980s or 70s or something like
Ah,
that.
Oh,
okay.
But they never
Okay.
got popular back then because there was no good hardware to run them on.
yeah, you need to use
Yes.
supercomputers or something at that point to do them, I
Yeah,
guess.
which are maybe taking up a large space in
Some
Physical
specialized
software
space.
labs.
Yeah.
Yeah.
apps.
Yeah.
Yeah, now you can do it
Okay.
on your backyard basement, wherever you want
Yeah,
to.
yeah. So that is one of the
I,
things which has really influenced this rise of neural networks in maybe the last 20,
okay.
30 years.
Okay.
So was it like during the 80s, the models people were working on suited probably the hardware constraints of that time, and
Yeah, yeah,
once hardware started developing, this neural nets became popular.
yeah. But
The,
yeah, you can see how research is kind of limited by the hardware that is available at each point
Okay.
of time.
so
Any
probably
point of
the
time. Exactly.
idea or the technique was maybe thought out back then, but it was only testable now on a large scale.
Yeah, yeah. It was. I mean, the papers about these kind of techniques were published at that time,
Hmm.
but they are used in a more mainstream manner only in the
Once the
recent.
technology
Yeah,
was
once the
good enough.
technology, once the hardware was good enough for it.
So now we're talking about the performance of the models, right? Like what are the factors that could influence the performance of a model? And you talked about like how hardware upgrades will not only help in running complex algorithms, but also help the model to learn the things faster,
Yeah.
right? So when you say learn things faster, I'm having a doubt whether the learning process of the model, is it like a continuous process, or is it like train the model for like 2 days and then it will give you accurate output, or it's going to continuously improve? How does it, like I can see some complex tech companies like Facebook, Google, they have a lot of these kind of models. I don't think that is like training it for 2 days and then like predict the result, right? It's continuously learning, right? But I'm sure in your projects, the models that you're using, you may want to achieve results faster. So you will probably train it for a day and then look at the results. How does it differ? Can you explain?
Yeah, it really depends on every company and use case. You can
Okay.
keep, I mean, you can train a model on some certain amount of data, and then once you get more data, then you can maybe just incrementally train the model with the new data, or train the model altogether with all the data that you have until that point.
Okay.
I think both, I think it depends really on the use case. For example, say you already trained the model on a billion images. Now you've got maybe another million images. You don't want to train the model from scratch again. You want to only update the already pretty good model and reach a even better state. Whereas if you only trained your model on say 1,000 data points and you got 1,000 more, then it makes sense to train the model altogether again, because it's not a lot of data anyway.
Okay.
And it really depends on every company. I mean, and how much hardware
Sorry.
resources they have. They can keep training the model over and over again every day or every week, or over whatever is best for them.
Okay.
Probably
So,
Google and Facebook have
Hari,
the resources to do it more often.
Yeah. Of course they do.
Yeah.
Yeah.
so Hari, one very interesting application of, say, an image processing algorithm that I have started to use very recently has been the face ID thing in my iPad right now.
Okay.
So the speed at which it's working is something that I was surprised by. I did not expect something to work so well. And what I was even more surprised is the fact that it works in very low light conditions. As in, even when all the lights in my room is off, just with the light coming from the iPad, it's able to recognize my face and unlock it, which was something very surprising to me. So how does something like that work? Does the model or algorithm in my device keep training itself, or they did the training already at an earlier time to identify a same looking face in low light condition, in good light condition? How does that work?
I'm not sure how exactly
So Face
Apple
ID,
does it.
as far as I know, does not use light. I mean, it uses light, but it uses infrared. So the low light condition does not matter for Face ID at all. You, in most cases, you can use it in almost perfect darkness, and it should work. It uses a, like, there's a small LED or something there that uses 40,000 lights points that identify the features on your face. And once it is set, then it knows who you are basically, or how your face looks like, regardless of light conditions. I do not know how machine learning
No.
comes in
Okay.
here, but I mean, I don't know the use of it here, but it probably is used in some format or the other.
Yeah, so it's going to learn some features from these points it projects on your face.
So it figures out that this, if it looks like this, it's a nose or eye or something like that.
Yeah, maybe a set of points around your nose is going to define how your nose looks like,
Hmm.
and some set of points around your eyes are going to define how your eyes are going to look like. So it's going to learn some features based on this,
Okay.
and then compare it with the initial. You would have scanned your face initially to register your face ID, right? So it's going to compare
Yes.
it with that to see if it
Yes.
matches those features or not.
When you mean features, does it mean, like, say, if there is point one and point two here, length of this point compared to, say, the length of my
Yeah,
eye?
yeah,
So
you can,
two
yeah, you
references
can
like that.
compare.
And does it also do something like find a ratio of this length to this length. If that ratio is constant, then it's this person. Does it
It
do
could
something
be doing
like
all of
that
them in
also
combination, I
extra?
think.
So it's kind of a blackboard. So it can learn whatever features it thinks is reasonable to identify a human face. But it's not something like defined by some human
Okay.
saying, find the length of the nose, find the width of the eyes, or something like that. It can learn something even
Okay.
more complex as well.
Okay. So it's not defined by a person. It's just something it learned on its own.
Yeah, yeah.
So could this be the reason why there are cases where Face ID can not work or open for other people? So there are documented cases, especially if you're a sibling, for example,
Hmm.
where it will still open.
Oh, okay.
Yeah, yeah, yeah.
Very
It's
similar facial
definitely.
features.
Yeah.
Yeah, so probably I mean, two persons can have maybe similar nose, but not all the parts of the face should be similar.
Yeah.
See,
Ideally.
that's the kind of
Unless you're a
logic
twin,
that
I guess.
Unless they're identical.
Yeah.
Yeah.
unless you're a doppelganger.
Or yeah,
But
identical twins.
Doppelganger.
Yeah.
yeah, the probability of that happening is quite low. And
Mhm. Yeah, Apple says on their site that for unrelated people it's 1 in a million that it'll open up like that. But for related people it's higher, which
yeah,
makes sense, I guess.
so if you have a twin, don't use Face ID.
Yeah, I am an advocate of fingerprint. Not that that's very secure either, but it's
Yeah,
I've also
I
seen
prefer
this.
fingerprint as well.
yeah.
I've also seen this use case where people just show a picture of themselves in front of the camera and see if that unlocks their device. And they're trying to use this to uh, measure how good a Face ID lock is compared to, say, a fingerprint lock.
hmm Yeah, Face ID has not been fooled by pictures as far as I know. Probably because it
Yeah,
uses depth as well.
Uh, not
yeah,
the
and I
Apple,
think
I'm saying
they
in
do.
other devices.
Sorry?
Hmm.
There are a lot of non-Apple devices also trying to
Yeah.
introduce Face ID feature, right? So
Yes.
I saw that they got duped in those instances,
Yeah.
and they're
Most of
using
the
that as
Android
a way
ones are
to
getting duped
say,
by it, except for the Pixel 4, whatever it had, because it used something
Yeah,
very similar to
hmm,
what Apple had.
many of the face recognition softwares are also trying to identify whether it's a real face or not before
Hmm.
trying to
Okay.
Mhm.
match the features.
Or is it a picture or is it an
okay,
actual face or not?
Yeah, is it an actual live person or
Yeah, it's
this?
maybe it's detecting motion in the face or
Yeah,
something
yeah,
like that.
I think yeah, definitely it detects motion. Like we can't like sit still or like
yeah,
look still even for a few seconds. Some movement will be there.
yeah,
Blinking maybe. Blinking
yeah.
is probably one thing they can detect.
Yeah,
Yeah,
blinking, small twitches, something will be there, I
yeah.
guess. Eyes moving a bit.
Since we talked about Face ID, there's another place where this thing is used. Machine learning is being used, right? You've seen all these deep fake videos, right?
Yeah.
Yes.
Deep fakes. There was an app which was very popular. Your same face
Face
as a
app.
girl, or like you 8 years later, the Face app.
Yeah.
So these are
Yes.
like some very interesting things where they're using this technology to. I don't know what they're using it for apart from having fun because there are some could be used for other purposes also. But
Yeah.
we are seeing a lot of this coming
fun.
up. Fun. Apart from fun. Fun.
Yes, a lot of
Yeah.
fun.
But again, yeah. So that is also like using similar technology to this. And maybe in the future, they are like saying even the movie actors, they'll be completely replaced. Even if they are like passed on, they can completely replace
Yeah.
their face on a different
Yeah.
actor, and then he will do the performance. And but you can see, for example, somebody like Robin Williams's face or something like that. Who knows?
Yeah, that's pretty
It's
cool.
possible. It's cool, but then it presents its own implications, right? Like the dude
Yeah.
is
Yeah,
not here anymore.
not here anymore. So, Hagi, is that something like similar to what you're working on? You're like detecting objects within images, right? Are you also looking for human faces and other things, or is just like certain objects within images?
No,
How
it's
does it work? Okay.
It's just certain objects.
Okay.
Maybe humans are something that I would try to detect, but not specific humans or specific faces or things like that.
Okay.
And going back to the kind of models that you're talking about in these kind of deep fake apps, these are called generative models. So they don't
Okay.
make predictions. Instead of making predictions, they recreate or they construct a new image itself based
Hmm.
on some kind of property that you want. Maybe you want to keep the face of one person and the body of another person, or maybe you want to keep the entire face same but maybe age it backwards or forwards. It's going to
Understood.
create an entire image, which is not a
Okay.
prediction saying, well, okay, this person is old or not old or something like that.
So
It's going to
yeah.
actually,
Okay.
So it takes the base expression and then someone else's features and puts them together, basically.
Okay.
yeah, so yeah, something like that. So it has to separate out these features which are related to age and which are maybe more common,
Hmm.
and then add these age features to your basic features and create this new image.
Does that
Okay.
mean like it
It's
is
like
more advanced
Photoshop.
or something?
Yeah, it's pretty
Yeah,
much
but that's maybe
Photoshop.
a lot more difficult to do in Photoshop because it's
Okay.
not so easy to, okay, take this image, separate out all the base features, and
Yeah, I
then,
mean it's Photoshop, but for a full-length movie.
yeah, I mean, but if you were to do this in Photoshop, you will maybe have to
It'll take
spend
a long time.
many hours to do
Yeah.
this. Yeah,
Yeah.
So basically, deepfakes are like Photoshop, right? Photoshop for videos, but since it's being
Not
done by
necessarily
an
for
algorithm,
videos,
it's faster.
Okay.
but it has lots of actually useful applications as well. For example, maybe you can take uh, medical imaging, which is again another field where machine learning is getting popular recently. So you don't have access to a lot of medical data because it's often confidential, or hospitals don't want to share this kind of data with
Hmm.
some kind of startup or company which is trying to do some work with this. So in this field, you can use this kind of generative technology to generate new images which look like real images and create more data for training your model. So in this way,
But the
Okay.
data will not be real, right?
yeah, otherwise
Exactly.
you
Yeah.
have very little data to train your model.
But the data is not real, so
Hmm.
you're testing it on something you think is kind of real.
Yeah, you are trying to create something which is as real as possible.
So there are
In
levels to
that
it. Like.
case, how do I say that that would be representative of the overall population? Because you have a limited sample set. You're creating samples out of that which are going to look maybe similar to that sample only. How will that be representative of the, say, overall
Yeah, but
population?
it's still going to be better than just using that limited data, right? It's going to uh, generate more data which are maybe in between these samples. For
So what you're saying
example,
is like if I have like a few data sets, the output of the generative models will be like a combination of data
yeah,
from different
yeah,
sets and
yeah,
give like a new data set.
yeah. For example, if you take human faces, and if your limited data set only contains faces of people from India, then it's going to generate more faces from India. It's not going to generate a new face which looks like someone from the Europe or something. So, but it's still going to be better than just using some limited data.
Okay, yep, that makes sense.
So interesting that we covered like deep fakes and face recognition technology and stuff.
Cool. Okay, so I think we've already covered a decent amount of ground. We saw what is machine learning. We saw some uh, good real life examples or analogs rather of how machine learning works and how the model is being trained. We went through a lot of topics like image processing and deep fakes. We saw language processing and how Google Translate does things. Um, and we are also running out of time. So what I think is we'll continue our discussion and we'll put that as the next episode, where we will try to tackle the implications of machine learning, how it is impacting our daily lives, where it's being used and how it's being used. Um, I think we still have a lot more to discuss here. So, thank you everyone for listening. Please follow us on our social media, Twitter, Instagram, wherever you're in. And if you have any questions for us or regarding any of the topics that we've discussed, put them down in the comments on YouTube or tweet at us on Twitter, where we will ask Hari to reply to your questions. So, take care, everyone, and see you in the next episode for the finale of machine learning. For now, bye bye.